Dear students, welcome to today's topic, Reciprocating air compressor, part 5. Today we will continue our discussion about volumetric efficiency. In the last part, we defined volumetric efficiency. Right, volumetric efficiency is nothing but it's a ratio between free air delivered and the safety volume. Before we start, I recommend you to go through part 4 for better understanding. So, we all know we define volumetric efficiency as the free air delivered at ambient condition divided by safety volume. Now, first of all, we consider two different states. The first one is the state or the condition at the end of suction or at the beginning of compression. The point 1 represents the end of suction or the beginning of compression. So let P1, V1 minus V4 and T1 be the pressure, volume and temperature at this condition, that is inlet to the compressor. P1 be the pressure, T1 be the temperature, and V1 and minus V4 represents the volume because this much volume is drawn into the compressor. And at ambient condition, we just Pam, Vm, Tm represents the pressure, volume and temperature of the ambient condition. Now you know the ideal gas equation. So when you substitute these values, these two states, when you in ideal gas equation, you get that an equation like this: P1 into V1 minus V4 divided by T1 is equal to Pm into Vm divided by Tm. From this equation, obtain an equation for Vm. Vm is equal to P1 into Tm into V1 minus V4 divided by P ambient condition into T1. You know the formula for volumetric efficiency, Vm divided by Vs. So I rearrange the above equation. When you divide this with Vs, right, we get the volumetric efficiency. I rearrange this equation as Tm divided by T1 into P1 divided by Pm into V1 minus V4 divided by Vs. I strongly recommend you to write along with me these equations so that it will be more clear. So now we have an equation Tm divided by T1 into P1 divided by Pm into V1 minus V4 divided by Vs. So what is V1? V1 is this volume, right? This much volume you know, that is the clearance volume, right? This is the clearance volume. This is the clearance volume, right? So, and this much volume you know that is Vs, safety volume. So I can, this is 1, right? So this is V1. So I will rewrite this equation as Vc plus Vs. Here in this equation V1, I replaced V1 as Vc plus Vs, clearance volume plus safety volume. The rest are same, minus V4 divided by Vs. Now when you divide this term, it will become 1 plus Vc divided by Vs minus V4 divided by Vs. I will multiply numerator and denominator with Vc. So it will become 1 plus Vc divided by Vs minus V4 into Vc into V4 divided by Vc into Vs. Now, what does 3 to 4 means? It is nothing but the polytropic expansion of the high pressure, high temperature gas in the cylinder, the clearance space, right? So, you know the formula for polytropic equation, PV raised to n is equal to constant, so that you can rearrange as P3 V3 raised to n is equal to P4 V4 raised to n. I will bring P4 to this side and V3 to this side. I will bring this n to the other side, so it will become P3 divided by P4 the whole raised to 1 by n is equal to V4 divided by V3. Now, look into this figure. What is P3? P3 is P2, right? So, I replace this P3 with P2. And what is P4? P4 is P1, right? So, I replace this P4 with the P1. So, P2 divided by P1 the whole raised to 1 by n is equal to V4 divided by Vc. Why I found the value for V4 by Vc? I need to substitute here. Here is one V4 is there and one Vc is there. So I need to substitute V4 by Vc in this P2 divided by P1 the whole raised to 1 by n. So when I substitute it, it will become like this. That is, when I substitute P4 divided by Vc, then it will become this Vc divided by Vs remains same, and this V4 divided by Vc I will substitute with P2 divided by P1, the whole raised to 1 by n. It can be written as P2 raised to 1 by n divided by P1 raised to 1 by n, no problem. Now, this Vc divided by Vs and Vc divided by Vs I replace with C. C is nothing but the clearance ratio. C is nothing but the clearance ratio. Its value is usually lies between 4% to 10%. 4% to 10%. So the clearance ratio is nothing but the ratio between the clearance volume and the shift volume. So when I replace this Vc divided by Vs as with clearance ratio C, then our equations looks like this. My final equation becomes the volumetric efficiency is equal to Tamp divided by T1 into P1 divided by Pamp into 1 plus C minus C into P2 divided by P1, the whole raised to 1 by n. This is the formula for calculating the volumetric efficiency. Now, you already know the volumetric efficiency is nothing but free air delivered at ambient condition divided by shift volume. And you know the formula for calculating the volumetric efficiency. So this is one of the important derivation which is commonly asked in university exams. Now, then comes under volumetric efficiency. So, what do you mean by volumetric efficiency? Volumetric efficiency is nothing but the free air delivered at suction condition divided by shift volume. Volumetric efficiency is nothing but the free air delivered at ambient condition, right? The main difference between overall volumetric efficiency and volumetric efficiency is that in overall efficiency, in case of suction condition, there is ambient condition. So the free air delivered at suction condition divided by shift volume is known as volumetric efficiency. So in this equation, when you replace this replace this Tamp, T1 and P1 by Pamp with 1, or if you didn't put this Tamp by T1, P1 divided by Pamp, then the equation will looks like this: 1 plus C minus C into P2 divided by P1, the whole raised to 1 by n. This is the formula for calculating the volumetric efficiency. Now, from the formula for calculating the volumetric efficiency, it is clear that the pressure ratio is always more than 1. This is the pressure ratio, P2 divided by P1, right? It is always more than 1, right? If it is less than 1, it will becomes negative. Then negative plus negative positive, the value of volumetric efficiency will be more than 100. Usually the value of volumetric efficiency lies between 65% to 85%. So it is clear from the above equation that the value of volumetric efficiency should be less than 100, right? If it is negative, that is, if it is less than 1, the pressure ratio is less than 1, then the value of volumetric efficiency will decrease. So will increase. So the value of P2 divided by P1 is always more than 1. It will be more than 1 because P2 will be the discharge pressure. The main purpose of compressor is to increase the pressure, and P1 is the suction pressure. And as P2 by P1 increases, the volumetric efficiency decreases. When you can see from this equation, when you substitute more and more values, that is higher values to P2 divided by P1, you can find that the volumetric efficiency is decreasing. So as P2 by P1 increases, the volumetric efficiency is decreases. And as the clearance volume Vc increases, then the volumetric efficiency decreases. It is also clear from this figure. That is, if we increase the value of Vc, you can find that the volumetric efficiency decreases. So we can conclude that both the pressure ratio and the clearance volume increases, the volumetric efficiency decreases. So the volumetric efficiency is decreased during the following get decreased due to the following reasons. The first one is increase in pressure ratio, then increase in clearance volume. Then when the speed is very high, the volumetric efficiency will definitely decrease. And as I told in the previous slide, the overheating of air when it comes in contact with the hot cylinder walls and the hot suction walls causes what? A decrease in volumetric efficiency. Now overall efficiency is clear and volumetric efficiency is clear, and we know the formula to derive, the equations for the the equations and the concept for the derivations to calculate the volumetric efficiency. Now the main difference between the volumetric efficiency and the overall volumetric efficiency is that for finding the dimension of the cylinder, we use the volumetric efficiency, that is the volumetric efficiency based on the suction condition. That's the main difference. If in numericals, if some question is asked to find the dimension of cylinder, you need to use the volumetric efficiency which is based on the suction condition, that is the volumetric efficiency at suction condition divided by the shift volume, that is effective shift volume divided by Vs. So in the previous slide we explained what is volumetric efficiency and we defined volumetric efficiency. In this part we explained the formula for calculating the volumetric efficiency, what is the difference between overall efficiency and overall volumetric efficiency and volumetric efficiency. In the upcoming videos we will be discussing how to calculate, we will discussing multi-stage compression, how to calculate the minimum work required for a multi-stage compression with perfect intercooling and all those things. Then we will do some of the numericals regarding this volumetric efficiency and the work done, etc. in the upcoming videos. So thank you for watching this video. Bye.